and welcome to Introduction to Epidemiology, CHP 320. My name is Brenda, and this is your textbook for the course. We'll focus on Chapter 1 on today's lecture of Epidemiology Matters by Catherine Keyes and Sandro Galea. So Epidemiology Matters is really about methodological foundations. So if you're unfamiliar with epidemiology, it's the science of understanding the causes and distribution of population health so that we may intervene to prevent disease and promote health. If you're thinking causes, I've heard this before, you might remember Link and Phelan from Fall Quarter. They were social epidemiologists who established that through evidence that social conditions are in fact a fundamental cause of disease or health. So some examples of questions that an epidemiologist would ask. What is the incidence of myocardial infarctions between 2010 and 2020 among women born in 1950 in the United States? When I say incidence, I mean the occurrence of a new case of the disease. Other questions they would ask are, what are the causes of MIs in this population? If we were to change population dietary habits, what improvement in MIs incidence could we affect? So in this lecture today and in the chapter, when you read, it'll talk about evolution of epidemiology, our approach to teaching epidemiology, and when I say our, I mean mine, but also Keyes and Galea, who are my professors. We'll talk about the 7 steps to conduct an epidemiologic study, the fictional land of Farlandia, and a quick summary of the chapter. So we'll start with evolution of epidemiology. Epidemiology is relatively new as a science, but it's been around for centuries. It's been around even longer in Eastern science, in China and India and parts of Africa, Middle East, where their medical systems are very old and very evidence-based, but it doesn't quite align with allopathic science, so we'll leave that out of the conversation for now. But diseases have been counted and cases have been counted and measured and surveilled for centuries. But many of the design and analytic techniques of modern epidemiology really came around in 19th and 20th century. So some of the main names in epidemiology that you'll hear about are John Grant, who was a 17th century scientist and pioneered approaches to tabulating population health and mortality in rates, ratios, and proportions, and we'll get into the distinction between those, which is subtle but important. There's William Farr, and you'll notice in your chapter 1 that Farlandia, the place that they'll be using a lot for examples and establishing concepts, so this fictional place was named after him. So he developed more sophisticated life table approaches, and if you remember demography, the demographic transition demographic tables. Life tables are a big part of demography and understanding the force and burden of mortality. So life tables, if you can imagine, are really looking at births and deaths in a population. John Snow, he might be the most famous of the lot. He is a 19th century, he's a physician in London, and he used epidemiologic approaches to understand the cholera epidemic at the Broad Street pump. You might have heard of it before. And so he developed and applied basic measures of disease frequency and occurrence. And we'll watch a video about that in your media. It'll be there in your Module 1 media. just how he used mapping and some really interesting techniques to locate the source of this cholera outbreak, um, or the originating source of the contaminated water. So more about the history. So in 19th century, if you remember the epidemiologic transition that we covered in fall quarter, uh, the first sort of phase of that was infectious disease. So that's pretty much right here. As you saw during the transition, it went from infectious to non-communicable disease. And if you forgot about our friend from University of Edinburgh, there's a few reminders here of the age of pestilence and famine, the first part of the epidemiological transition. Um, so there's infectious disease, war, famine, quite a bit till mid 1700s, receding pandemics, nutrition, sanitation issues, less medical care, and then the next transitionary period, which is non-communicable. And I think at some level, some of these, but most of these are non-communicable disease. So that was our friend from University of Edinburgh, his video, who we saw last quarter, just making that distinction between the different periods during the epidemiological transition. So finally, in the mid 20th century, the 1970s, methods were formalized, and in the 80s and onwards, Rothman, Maittinen, and Greenland sort of coined and formalized central disciplinary principles of epidemiology. So current conceptual movements that I would like you to know for this chapter are the eco-social perspective on population health, which suggests policies, institutions, characteristics of context, that is, our life surroundings, contribute to the shaping of health. The other concept that's really important is life course perspective, and I think we briefly spoke about that in fall, but it's really the determinants of health that are distributed across the life course and even before conception in the period of gestation. So, therefore, epidemiology understands causes of population health across levels of influence from cells to society and across the life course. So just to dive into the eco-social framework a little more, it was there in your Nancy Niles textbook. Very briefly, we covered it, but more about it. Now that you have more understanding of sort of law and advocacy and basics of community health from the last few quarters, it should be coming together that these social and economic policies, as we saw in SICO, have a huge influence on an individual's health and a community's health. The institutions, the schools, the prisons, hospitals, and many of our institutions in society also have a huge influence. Neighborhoods and communities, often health is measured at the level of a neighborhood or community because it's quite often the case that social conditions are similar for people living in the same community. Living conditions are at the level of the family usually. So one family, if we're talking about an exposure such as mold or even violence, that's at the level of family or living conditions sometimes, or it might be at the larger level depending on the exposure. Social relationships are an individual unit, but they're also, if we think of it in a sense of kinship, which is family, or at a cultural level, social relationships can also differ in a broader sense based on culture or values or or isolation or geography. So this is very important too. Individual risk factors. So my own diet, my own exercise, my own habits, those are more individual risk factors. Genetic and constitutional, what we're born with. Pathophysiologic pathways. This is important too because often we think that disease process is the fixed idea, but for each individual, for each, you know, unit, even if it's across maybe some of these lines here, is different. So this disease process and pathophysiologic pathway is also part of this eco-social framework, and again, individual population health, which is affected by the environment very much and the life course. So sort of the outer environment of our society and our living space and whatnot, and the smaller environment before we're born, which is gestation. So just a deeper look at the life course approach to health production. So in the context of, say, any disease, we can choose cancer. We look at fetal life, which would be the mother's nutrition, carcinogen exposures, so maybe eating something toxic or taking a medication, fetal growth, birth weight. And then there's infancy and childhood, breastfeeding, micronutrients, contaminants, growth rate of the fetus, stature, behaviors, physical activity in childhood, and growth rate of the child, that was the fetal life, and food choices, obesity. Again, we get into adolescence, smoking, contaminants in the air and food and water. We see this as a sort of a thread, the environment through this whole process. There's the timing of puberty in adolescence, obesity, but there's also starvation, and in many societies and places right now in the world, obesity may not be an issue, but other nutrient deficiency and protein and energy deficiency may be a problem. So, like, for example, in Yemen, where there's a large-scale famine. So, physical activity, inactivity, is part of that production of health, especially in our youth. And adult life, pregnancy and lactation, we all know our own adult risky behaviors that we do, whether we know or not what is right. We all have the risky behaviors. And so there's diet, physical activity again as an adult, tobacco, alcohol, ingestion of dangerous products, and then the older ages. So you see the accumulated risk is just growing and growing and growing. And the genetic susceptibility mostly stays the same, but can you imagine why it changes a little, which is from the gene-environment interactions. So say we have the gene, and according to epigenetics, or that gene-environment interplay, maybe my lifestyle or my environment can trigger the expression of that gene in an older age. So next, our approach to teaching epidemiology, and when I say our, I mean mine, but I also mean Galea and Kais. So we'll be using this book throughout the quarter, and I would like to thank them. As I said before, Dr. Galea was my professor in graduate school, but mainly I'd like to thank them for encouraging us to develop an epidemiology of consequence and consider what that means. Are there consequences to showing vulnerabilities of populations, putting that data out there and showing this kind of information? So enjoy the chapter and see you next time.